Okay, in the last video, we looked at adding and subtracting rational expressions. Now, I thought it'd just be a good idea to, if you need some more practice, need some more examples, that I would do another example here. So let me write this down here. We have a divided by a squared plus 7a plus 12. And let's do a subtraction problem. Let's see what that looks like. We have a squared plus 9a plus 20. Okay, in the last video, the first thing we did is we factored the bottom. Okay, and so we're going to do that same thing. We got to know what parentheses that the left side has and what parentheses the right side has so that we can get them both to be the same. So on the bottom, we're trying to look for what multiplies to 12 and then adds up to our middle term 7a. And if you think about that, it's going to be a plus 3 and a plus 4. On the right side, we're looking for what multiplies to 20 and adds up to 9. All right, so that would be a plus 4 and a plus 5. All right, so let's transfer all of this to the next page. And let's see if we can figure out what that problem will look like. Okay, so again, we're looking for what the left side has that the right side doesn't, and what the right side has that the left side doesn't. Again, we're just trying to make sure that everything on the bottom is exactly the same. If it doesn't have it, we're going to multiply top and bottom by those in order for them to be the same. So again, looks like we have an a plus 4 and an a plus 4 that is common between both denominators. So let's look at the right side. What does the right side have that the left side does not? And that is an a plus 5. So we're just going to add that by multiplying, just like we did on simple ones with numbers. And we're going to multiply the top by that same factor. Because this is just a fraction. Whatever I do to the top, I've got to do to the bottom. And we're going to do the same thing on this side. We're going to say, okay, well, they both have a plus 4s and a plus 5s, but now this left side has an a plus 3 that the right side does not. So we're going to multiply the top and the bottom by a plus 3. Okay, so this is what we have now. We have a and then a plus 5 divided by all that good stuff on the bottom. It's kind of tedious to write all this out, but it's necessary. We have a plus 4, a plus 5, and a plus 3. Let's write that a little bit better. A plus 3. Okay? And so now that the denominators are the same, I can now write them as one fraction with just all three parentheses under one fraction. And so it's going to look like this. Let's take a look here. We have a plus 5 minus 3, a plus 3. And then we have, that's easy, a plus 3, a plus 4, a plus 5. And the order does not matter in which you write these parentheses. As long as you have each one accounted for in each fraction, it's okay to write them in any order you want. So I just wrote them as I see it there. Now we're going to distribute, just like we did in the last problem, we're going to distribute the a and the a to the a and the 5, so that would be a squared plus 5a. Now we're going to distribute the negative 3, making sure that you distribute a negative 3 because the problem was a minus. So that'll give me negative 3a minus 9. Okay. And then we have a plus 3, a plus 4, and a plus 5. The last thing we need to do is just find any like terms. And it looks like I do have some like terms right here. And so it's going to be a squared plus 2a when you combine the 5a and the negative 3a. And then we have a plus 3, a plus 4, and a plus 5. As soon as your fractions are together and you've simplified the numerator, you're probably more than likely going to be done, in which this case we are finished. Let's just do one more and get a little bit harder now. So another practice problem. Let's say x minus 8 divided by 4x squared plus 21x plus 5 plus, and then 6. So again, we want to do the same thing. We want to factor the bottoms. Okay, now this one over here, I don't have to do anything like what multiplies because I just have a single degree here. And so we're just trying to figure out what can I divide 12 and 3 by? Let's make that a little bit lower. What can I divide 12 and 3 by that goes into both evenly? And it looks like it's going to be 4x plus 1. And then we have a 6 on top. Now this one factors a little bit differently, so you can do either slide and divide like we've done in class, or you can do the box method. I will do the box method. Now before we do that, let's check to see if there's any GCF between 4, 21, and 5. If there was a GCF, you would be able to pick a number that divides into 4, 21, and 5 at the same time. And there is nothing like that. So we can start right away with the box method. So off to the side here, let's put our box down. Remember, the first term goes inside the first box, and the last term goes inside the last box. And then we multiplied the two numbers inside, ignoring the variables, and we got 20. Now, just like on the last type of factoring that we did, we're going to figure out what multiplies to 20, and those same two numbers have to add up to our middle term, which is 21x. And if we work through this, it looks like it's going to be 20 and 1, and then 20x and 1x. I put x's on because I need x's when I put the remaining two numbers inside those boxes. And I'll tell you why here in a minute. So now that we have these, we're going to take these two numbers right here, the 20x and the 1x. We're going to put 1 in one box and 1 in the other. And then now, if you remember from class, we're going to just find the GCF between these two. What's the GCF between 4x squared and x, or 1x? And in that case, it's going to just be x. I repeat that process for all pairs going vertically and horizontally. Actually, I'm going to should my arrow go this way. So what is the GCF between, let's just say, this 20x and the 5? So I'm looking for what number divides into both of those evenly, and it would be a 5. And so this is actually going to become my first parentheses when I go to factor my 4x squared plus 21x plus 5. I'm going to do the same thing over here. What is the GCF between 4x squared and 20x? Well, I can divide the 4 and the 20 by 4, and they both have 1x. So 4x would be my GCF. And then on the last two, this 1x and the 5, well, actually, they don't have anything in common. There's nothing I can divide 1 and 5 by beyond a 1, and in this case, that's what we're going to do. We're going to have a 4x plus 1. And so if we come back to here, we can now say that this factors into x minus 8 is just going to stay the same on the top. And then this x plus 5 becomes one of my factors over here on the box method. And this 4x plus 1 is also going to be a factor that I have on my left side. Okay. So now let's take this over to the next page where we have some more room. Okay. So now again, we're trying to figure out we're trying to get both denominators to be the same. So we're just going to add what one has that the other does not. And when I mean add, I mean we're going to multiply the top and bottom by that. So if we look on the right side, this right side has a 3 on the outside of the parentheses, and this over here does not. So we're going to multiply the top and the bottom by 3. We have to account for that 3 on the outside in order for the denominators to be the same. We're going to do the same thing on the right side, except for the right side does not have an x plus 5. And so we're going to multiply the top and bottom by x plus 5. Okay. Now, maybe to skip a step, we could just write it like this. Now that the denominators are the same, I can write it like this. Save us a little bit of writing here. So all of this matches with all of this. And so I can write the two numerators to be this on the denominator together, or sorry, on the numerator together. And then I can just write this once, x plus 5 and 4x plus 1. Again, we need to simplify the top, which means distributive properties. So let's take this and distribute our 3. 3 times x is 3x. 3 times negative 8 is negative 24, plus, and then distribute the 6. 6 times x, 6 times 5, that's 6x plus 30. And then we will have our denominator just brought across, because it's not going to change. Combine like terms and we're finished. So we have our 3x and our 6x, that's 9x. Negative 24 and positive 30 was be 6. And then we have our numerator. And again, we have got our fractions to be common denominators. We put the numerators together. We simplified the numerators by distributive property and then combining like terms. And at that point, this is our answer. Thank you. If you have any questions, let me know. If you want more examples, let me know. I will try to respond as quickly and as efficiently as I can. But please let me know if you have any questions.